There are a few different ways that you can approach a complex fraction, which is what we're looking at in number 6. Now, sometimes when we have vocab words in Excel Algebra 2, the names aren't really appropriate, but I think this is one of those cases where the name is exactly appropriate. Let's go back up to the definitions at the beginning. The one definition here we have is a complex fraction. This is a fraction or rational expression which contains a fraction in the numerator and or denominator. So basically a complex fraction is a fraction inside of another fraction. And I know right about now you're thinking, wow, because I liked fractions so much before, I wanted my fractions to contain other fractions. I know, it's amazing. All right, so here we go. Let's take a look. We're asked what is a simpler form of this complex fraction, or it could just say simplify. So there's a basic process that we can follow. There's a few different ways to teach this. This is the particular process that I like to use. So it's a 4-step process. Process number 1 is to make the numerator a single fraction. So we look at the numerator as if it's the whole problem. And we say, well, what would I need to do to be able to subtract these two terms from each other? Well, I would need them to have a common denominator of y. The second fraction already has that denominator, but the first fraction, we would have to multiply by y over y in order to make that happen. So that means my numerator would become 3xy minus 1. So the numerator is a single fraction. I bet you can guess that the second step is to make the denominator a single fraction. So we do the same process, but we look at the denominator and we ask ourselves, okay, what would I have to do to be able to add those together? Well, I would need to have a common denominator of x, so that means I have to multiply this second term by x over x. So my numerator would be y squared plus x squared. Then we remember that this big division bar in the middle, it's a division bar, right? When we see it, sometimes all we see is the fact that it's this giant messy fraction. But it's not so much a fraction, and it's really more of just a division problem. So we're going to rewrite the problem as multiplication. When we do that, we're going to take the first fraction, 3xy minus 1 over y, and multiply it by the reciprocal of the second fraction. So x over y squared plus x. And then step 4 is going to require us to actually multiply. So we'll do the problem just like the multiplication problems that we've done in the past. Now, if I can factor, I will, but looking at each of these numerators and denominators, there's really nothing to factor. So it's just a matter of multiplying straight across the top and straight across the bottom. So we're going to have 3x squared y minus x divided by y cubed plus x squared y. And that's the best that problem gets. So that's considered the simpler form, the simplest form of this fraction. All right, finally, we have what's called a combined rates problem. So let's start by reading the problem. It says your internet connection has a download speed of 1400 kilobytes per second and an upload speed of 350 kilobytes per second. All right, so we all know this problem's outdated like a lot of the problems that we see, but the purpose behind the problem still makes sense. So we're going to ignore the outdated upload and download speeds. It says if you download a picture to your computer and then upload the same picture to your blog, what is the combined rate for the entire process? Okay, so notice they're not telling us how many kilobytes are being uploaded or downloaded, but they are telling us that we're downloading a picture and then uploading the same picture. So the implication is that however many kilobytes of data are in this picture, we're downloading that same amount and then uploading the same amount. So it's a consistent thing. So overall, I mentioned we're looking for something called the combined rate. So that's the rate of the two things happening together. And it really helps if you think about what are the units here, right? Kilobytes per second. So I've got kilobytes per second. And per triggers this division bar. It's really a division problem. So we need to think about what are we doing? Well, first we're going to download some kilobytes. And then we're going to upload the same number of kilobytes. And then the number of seconds would be how long do we spend downloading plus how long do we spend uploading, right? Because that would be the total amount of time. That would be the combined rate of these two actions happening. Now, we mentioned we don't know how big that picture is, so we don't know how many kilobytes are being uploaded or downloaded. And in algebra, when we don't know something, we call it x. So let's let x equal the number of kilobytes in the picture. So that means we're downloading x kilobytes and then uploading x kilobytes. Now in the denominator, we need to think about how long is this going to take. Well, they didn't tell us that. Instead, they told us something about the rate. Well, we have a speed here, and it's kind of like distance equals rate times time sort of scenario. If you think of distance equals rate times time, you could divide both sides by the rate and find out how long it takes to do something. Well, this is a similar scenario, except it's kilobytes equals the rate at which something is happening times the amount of time you allow that thing to happen. So if we divide both sides by the given rate, then we would have the amount of time spent uploading or downloading. So if I think about that, the amount of things I'm downloading is x kilobytes. And that's being divided by the download speed, the rate at which we're downloading, which is 1400 kilobytes per second. And then to that, I would have to add the upload time. Same idea. I'm uploading x kilobytes at a rate of 350 kilobytes per second. So we can see we have a complex problem to model this combined rate. But this is a complex fraction that we can simplify. My numerator is not too bad, right? Because we always said step 1, simplify the numerator. So we've got 2x. Step 2, simplify the denominator. Well, when I look at this, I want to think about getting a common denominator. So if I multiply each of these fractions by something over itself, I can get that common denominator. Well, 350 times 4 would get me 1400. So I actually don't need to multiply the 1400 by anything. I can just multiply the 350 by 4 over 4. So that's going to give me a single fraction for the denominator of x plus 4x, which would be 5x over 1400. And then we know from the previous problem we can rewrite that as a multiplication problem. So I have 2x times 1400 over 5x. Well, that gives me an x in the numerator and an x in the denominator. So it actually shows us that it doesn't matter how big that picture was, because the actual size of the picture cancels itself out in the problem. I can also look at 1400 and realize that that ends in 0, so it must be divisible by 5. So I can take and divide 1400 by 5, And this simplifies down to 2 times 280. Well, that means that I've got a combined rate of 560 kilobytes per second.